Hello and welcome to the Sensibly Speaking podcast. This is Chris Shelton, the critical thinker at large, coming at you on iTunes, Stitcher, Google Podcasts, iHeartRadio, and with video on YouTube, of course. This week, I welcome back Dr. Jonas Kaplan, and he is a cognitive neuroscientist who operates out of Los Angeles at the University of Southern California. And he has been on the show a couple of times, and we have had the most fascinating discussions about the brain, about neurons, about how it all works up there, about what is and isn't happening, and we really just scratched the surface. I just find this stuff endlessly fascinating because here we are dealing with the sort of heart and soul of thinking. What is the seat of thinking? Well, you can have ideas about souls or spirits or whatever, and those are nice ideas to have, but we can't measure any of that. We can't do a whole lot with souls and spirits, but we can do things with neurons, and we can talk about glia, and we can talk about action potentials, and we can talk about all these interesting things that happen in the brain, and it's sort of this mega supercomputer in our heads, and it's the most complex organ, the most complex mechanism we're aware of in this universe. So diving into this is a lifetime research type of job, and Dr. Kaplan has agreed to join us again to discuss more aspects of this. Hey, Jonas, how's it going, man?
Good. Glad to be back.
Have you back. You've been doing some interesting research in the time that we've been away. Can you talk about any of that publicly, or?
And I mean, we're doing some research, like everyone, we're trying to pivot to doing what we can during these times. And what I normally do is brain imaging research, and we can't do that right now because we can't have people come into the lab. It's not safe, maybe pretty soon. So we're all pivoting to find other ways to study the things we're interested in. And one of the things I'm interested in is how people change their minds and how they resist changing their minds. And this is, this COVID pandemic is actually presents an opportunity to study that because we're looking at some beliefs that have become really politicized around mask wearing and some of the health behaviors that have been recommended by our health professionals that people are resisting in the same way that they've resisted other health advice like vaccines, which is probably going to be another thing we're going to have to deal with soon. Hopefully we have to deal with people resisting vaccines. But so we're studying why it is that people are against wearing masks, because some people are, and if there's anything we can do to change their minds. So this is research that we can do online by just asking people questions and by giving them information, and that's what we're working on now.
Awesome, and very, very necessary. I just read this morning in an article talking about the vaccine situation, where things stand with vaccines, how they're pushing it directly as fast as they can, and there are multiple agencies working on this, and according to the NBC News article I read, 1/5 of Americans polled said, nope, I ain't taking the vaccine when it comes out. And that's a huge number if true. That's just one report, so we can't say for sure that NBC News is nailing it on that. But 1 out of 5 is definitely way too many people out there. And the mask situation is a flag or marker of how politicized and divided we become on such a simple thing as wearing a mask. It's unbelievable, the sort of motivated reasoning that you see expressed by people on the subject.
Yeah, there's so much going on in the psychology there. I mean, for one thing, it's a symptom of the underlying distrust of science that Americans have right now. And in our research, we found that's one of the best predictors of whether or not someone is going to wear a mask or not is, how much they trust science and scientists. And, the trust among certain political groups is pretty low right now. And that is a problem for us for all kinds of reasons. I mean, this is probably the most obvious reason, the health effects of not wearing masks and taking vaccines, but this is a disease that really infects our society. And until we find a solution for getting people to trust knowledge and science and the process that we have for developing what we understand is the truth, we're going to keep encountering all of these problems.
Yeah, very much so. It really wouldn't take, the way I see it, I think it would take really only a dedicated effort on the part of some key conservative leaders. And of course, I'm going in that direction because that's where the anti-science dogma seems to come from, and we relate it to evangelicals and religion and stuff, but it's not just a religious issue. This is just anti-authority, anti-science, and it can be regarded as itself. And I think that if we had some powerful opinion leaders on the right come up and say, hey, no, we got it. Come on, let's stop this. Science, man, science. At the end of the day, it's science. Your cell phone is science. Your television is science. The internet is science. We use science all the time, guys. There's nothing wrong with it. So let's just extend some trust and let's stop politicizing this. I think if we can get past this COVID thing, we can hopefully get readers, get new leaders arising from this. I know I'm being terribly optimistic right now, though.
I'm optimistic too. I think optimism is warranted. I mean, for one thing, the leadership at the top is a problem, right? So there's some early data that when Trump decided to wear a mask, that mask wearing among conservatives did actually increase. And so there is a real effect of authority from the top. And if we can change that authority to one that respects and trust science, that will go a long way. That's not the final solution, but I think that is a big part of it.
I agree completely, and I hope that happens. And my sociological mind kind of goes in the direction of pendulum swings and how society tends to go to an extreme end on things. This is, I think it's most easily seen in trends, fads, things that capture the public's attention. These are sort of microcosms of the larger pendulum swings we see. And I think this anti-authority sort of trend is something that'll go to an extreme end. Hopefully, we're at the end of that with this mask business and the vaccine business. And we can see it start, people start realizing or waking up when things get too extreme. They start going, wait a second, this is, people are dying. This is crazy, right? Then the facts of the extremity of it starts to, kind of pull back.
Of the extremity of it and starts to swing back. I hope you're right. I think you're probably right.
Eventually it'll happen, but it's hard to make it happen. You can only sort of push in a direction and hope that people catch on and things go viral and whatnot. So we'll see how this plays out. But I'm glad you guys are on it, because we need that work being done. And I'm glad to be talking to somebody who's actually doing that work, because it's important stuff.
Do what we can.
Well, let's go ahead and talk neuroscience for a little bit. This is an episode that I've actually really been looking forward to, because we're going to talk about memory. And this is something I am keen to find out about. I have so many questions. So first, I guess let's go ahead and start with the basics. If I'm reading things right or remembering things right, there are a couple different systems operating in the brain when it comes to memory. There's long-term and there's short-term. How does that break down? Am I right in that? Are there two different sort of sections going on there, or how does this work?
You're right. There's more than that. I would say there are many different sections. And the first thing for us to probably note, and this is I think actually one of the important contributions that neuroscience has made to psychology, is to understand that memory is not a unitary phenomenon. We use the word memory in our language as if it's one thing. But when we look at the brain, there isn't one thing that constitutes memory. There are many different systems, and there are many different kinds of memory, and we can start to see what those different kinds are and how they're separate from each other when we look at the brain. We look at, for example, the effects of brain damage. So one of the first clues that there are different systems for memory in the brain came from a very famous case of brain damage. This is probably the most famous case in all of neuropsychology. This is the one they're going to teach you about when you take your first intro to neuroscience class. And this is a neurosurgery patient in the 50s. His initials were HM. Back in the day, they used to use initials to try to protect the anonymity of the patients. Nowadays, I don't think initials would be considered very strong anonymity. And this patient has since passed away. We know that his name was Henry. But HM was suffered from epilepsy. And the focus of the seizures was in the temporal lobe. And so they did a neurosurgery to remove parts of his temporal lobe, including the hippocampus, which is a structure that's deep within the temporal lobe, and some other surrounding tissues. They removed this on both sides. It's a pretty drastic surgery for a pretty drastic form of epilepsy.
That sounds really invasive. Wow.
Pretty invasive. People did this kind of thing back in the 50s. They were based on animal models. You'd first do it in an animal and find that there was some kind of a benefit. And you also have to remember that this is before we had good drugs for controlling epilepsy. So there's really no other alternative. Someone's having seizures all day. You could do drastic things. So they took the temporal lobes and the hippocampi out from his brain, and for many intents and purposes, he seemed normal. He seemed intact. He could think. He could talk. He could see and perceive. But he had a very severe deficit in his memory, which was that he could not form any new memories after the surgery.
Right. Okay. This is maybe in terms of what this would look like. Is this something like Memento, that movie where the guy just could not keep up for longer than about 10 or 15 minutes at a shot?
Yeah, that's right. Memento is basically based on this patient, and he was not able to form new memories of a certain kind. We'll get into that in a moment. But complete amnesia, complete what we call anterograde amnesia, which is the ability to form new memories. He did not lose all of his old memories. Right? He still knew what his name was. He knew where he grew up. He lost some of his more recent memories. That's called retrograde amnesia, when you lose your memories of the past. But he lost his ability to form new memories. So, for decades, people would come and see him, and they'd have to introduce themselves every time they saw him, right? But it turned out there were some things that he could actually learn, and this is where the dissociation between the different memory systems is revealed. He was able to learn things like skills, for example. So
they actually touched on the movie a little bit with conditioning.
So conditioning is a slightly different form of memory. And I guess we're going to have to map all these things out. But for now, we'll just call it procedural memory, which is your memory of how to do things. So like, you know how to ride a bike. And that's sometimes people call it muscle memory. It's not really in your muscles. It's really in your nervous system. But muscle memory of how to do things, like he could learn how to draw while looking in a mirror. And he'd get better at it every day. But he'd never remember the last time that he did it. For him, he thinks he's never done this before, but you can see improvements happening in his skill each day. So that taught us, so much about memory in the brain. First of all, that this kind of formation of what we call explicit memories that you can talk about, things that you know, like what's the capital of Wyoming? What is the capital of Wyoming, Chris?
Cheyenne.
Yes, very good. So that's an explicit memory. You know that you know it, as opposed to these more implicit forms of memory, things that your body just kind of knows and you can't really tell. I know how to ride a bike, but if my daughter doesn't know how to ride a bike, I can't just tell her and then she knows. So there's different systems in the brain for these different kinds of memory, and the hippocampus and the medial temporal lobe seem really important for this kind of explicit memory, learning about experiences and facts. Whereas other systems of the brain seem to be important for learning how to do things, learning skills.
Interesting. So we have different types of skill sets, different types of activities being kept track of, I guess you could say, or being stored somehow in different ways. That itself is a fascinating thing to know.
That's right. And we can break it apart further. So these implicit memories, things that we don't know that we know, there are different kinds of those. You mentioned conditioning. And that's one form of memory. That's where you learn an association between two events. So, the classic experiment of Pavlov's dogs, where he would ring the bell and they would salivate because they knew that the food was coming. They learned an association between the bell and the food, and that's an implicit form of memory. It's not like they had to think, oh, gee, it's time for food. It's just happened automatically. And we have that form of conditioning as well. We can learn associations between things and not even know that we know those associations. There are other forms of implicit learning, like habituation and sensitization. So habituation, where you just kind of get used to something. There's a loud noise outside your window every day, and the first time you hear it, you can't sleep. But then after a while, you don't even notice that it's there. So that's an example of habituation. So there are all these different ways that experience can change us.
Exactly. And it also ties to the other things we talked about, because, for example, you brought up the thing just now about how you hear the noise and it just becomes part of the environment, and then your brain isn't really alerting you to it anymore at a conscious level. It's still processing the fact that it's there. The ears are still picking up those sound vibrations, but it's not alerting you to the fact that that it's there anymore. And this happens with smells all the time. I think this is where this is most prominent, at least from my own experiences. I mean, you walk into a room and it smells, but, after 10 minutes or so, you're not smelling it so much anymore. And this is why your own house sometimes needs defumigation, because people go to a friend's house or a relative's place and they're like, Jesus Christ, but they're not aware of it anymore because they've just become used to it. So it becomes something your brain doesn't have to alert you to, because the smell becomes a predictable part of your environment. It's not really a threat to you. So there's no reason to be alerting you to it. So it just kind of fades into the background.
Very well said. Very common among people who live with cats.
Yeah, that's right. That's right. Even we have Seven the Wonder Cat. It's still like that.
Different kinds of memory, like conditioning or habituation, sensitization, they all involve different neural mechanisms. So there isn't one mechanism that underlies all of these different things. There are different neural mechanisms, and this collection of ways in which the nervous system can change and respond to experience is what we call memory. But it's really all these different things. And one of the other big distinctions that we haven't even mentioned yet, well, maybe we did briefly, is the distinction between short-term memory and long-term memory. So short-term forms of memory, and those involve things like sensory memory, which lasts maybe milliseconds. So when you see something, you can close your eyes and kind of still see it there. Maybe when you're hearing my voice, you can reach back into the last half a second or so and bring back what I said, even if you weren't paying attention to it. It's kind of what we call echo memory. It kind of echoes in your mind. And then there's what psychologists call working memory, which is kind of, how you keep alive information temporarily while you're keeping it in mind. So, for example, if I tell you a telephone number, we don't remember telephone numbers anymore. Back in the old days, to tell you a telephone number, you had to rehearse it on your way to the phone. You're like 555-1212, 555-1212. And that kind of rehearsal is part of this working memory system. It's kind of like a whiteboard that the brain has for keeping information online and manipulating it and using it. And that's very different from, that lasts maybe on the order of seconds. So those are both forms of short-term memory. And if we don't rehearse that number, it'll disappear into the ether. It's gone forever, right?
Well, exactly. In fact, maybe this is a place to connect the shorter and the longer term, because then we can also take that number we're practicing memorizing, working on, and then somehow it clicks and it's sort of stored, and then it's awful hard to get rid of.
Yeah, that's right. So that process of just to jump in there, the process of moving from short-term to long-term memory, that's probably what, it's one of the things the hippocampus is really important for. That's what Ethan couldn't do. He could keep the phone number alive. He could say it right back to you. But it would, as soon as he stopped saying it, gone forever. He had no way of making it stay longer.
Right. That's the hippocampus working on that now. Is it a matter of, do we think about this in terms of building a mental model around this time? We think about the hippocampus as is it like a gatekeeper to a storage area? Or do we think of the hippocampus as the storage area?
It's definitely not the storage area. And we know that because when you take the hippocampus out, you don't lose all your memories. So it's not like a hard drive. And in fact, the interesting thing is there doesn't seem to be a single storage area. There is no one particular place in the brain that you could take out and just remove everybody's memory of who they are. I don't know if you remember, they used to do this in cartoons all the time, where somebody would get hit on the head and they just don't remember anything. They have that kind of what we call retrograde amnesia. They used to just call amnesia. They forget everything. They don't know who they are. And then maybe they get hit on the head later in the episode and it comes back. But there's no place in the brain that you can just destroy and create that kind of amnesia. So memory is the actual location of memory seems to be distributed around the brain. And in order to really lose your memory, you have to have widespread distributed damage of the kind you have when the whole brain starts to deteriorate, like with dementia. So, for example, with Alzheimer's.
Or I think rabies attacks the brain that way also. I just happened to read that the other day. I was just about the horrors of rabies, and it was truly horrifying. I mean, the experience of somebody that this is happening to, but I didn't realize. I had no idea that rabies was a nerve deterioration disease. So that's why it was fresh in my mind. That's interesting. So it's a distributed sort of thing, and this is where we're gonna. I think this is where we're gonna bump up against people's mental models of how memory works. is because they sort of have this idea, but it's like this, that the brain sort of has this refrigerator section where you store stuff, and yet you make the point, a very good one, that it's not like you can just take an ice cream scoop to the brain and, okay, we're going to take this part out, and now you have memory, that now, yet we do have memories. So there is some mechanism there that is driving this or storing these images. How do we know about this? These images? How do we know about this stuff?
Yeah, so I think you actually said an important word there, which is images. And memory does work through images. And what images means are sort of mapped representations, and they don't have to be visual. There are auditory images that we have as well. You can bring up sounds in your mind's ear. You can kind of remember what something sounds like. And what we've found, one of the things that we know is that the brain recreates these experiences for us, in a sense, when we recall memories. So when we recall a memory, and we have a mental image that goes with that memory, like if I asked you to think of, when you walked outside yesterday, what did it look like? You can picture that in your head. That's a memory. Your brain is using your perceptual mechanisms to recreate a kind of pseudo-perceptual experience for you. And it uses, for example, with visual imagery, it's going to use the visual cortex to do that. And so we can actually see, when we look in the brain when people remember things, we can see the sensory cortices activating in very specific ways. We did an experiment a little while ago where we asked people to recall the sounds of various objects. We'd cue them with like a visual stimulus that looks like something, like a rooster crowing. You hear the sound of the rooster crowing in your ear. So it's a memory. And we looked into the auditory cortex, and we found that the patterns of activity in the auditory cortex were so specific for each memory that we could use machine learning to decode what the person was actually experiencing. So we could tell from their brain activity, are they now experiencing the sound of the rooster? Are they now experiencing the sound of a violin, or the sound of a vase crashing, or something like that?
Wow. Based on that, do I have it right then that they would first tell you what it was they were thinking?
Tell them what to think. So we say, now we want you to think of a rooster. Now we want you to think of this other object that makes a sound. And then we look at the brain activity. We know what they're experiencing, but we don't tell the computer algorithm what it is. And the computer algorithm can still guess, based on the brain activity, what it was that they were experiencing.
Wow, that's pretty interesting, because prediction leads to all kinds of things. I mean, if you can predict, if you can nail and identify, then you can manipulate, control, if you invent. I mean, there's all kinds of things you can go from there. And I don't mean this in some nefarious 1984 way, but that's where my brain goes because of my background.
It's a lot easier to read brain activity right now than it is to create specific patterns of brain activity from the outside in.
Right.
But like a mind reading exercise, and for us, it tells us where the information is in the brain. There's information in sensory cortex about what it is that you're remembering, and so it teaches us about this process that the brain is using to regenerate these images for us in our minds, and it uses these sensory maps that we have that we use to perceive. It uses those to remember, to create images.
Wow. Is there an indexing system of some kind, or a table, like you go, okay, this map equals a rooster cawing, right? This and this and this, these neurons fire in this sequence, and that's the memory of the rooster cawing. Is that information like on a hard drive? You have an index or a table, that tells you where the information is stored. And then you go there, and sure enough, there's the information. Is there a similar mechanism in the brain as well, as a central hub of a table of contents or something? Or how does it, like rooster, okay, boom, 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 fire those neurons off, Yes,
I do know what you mean. It's a really good question. I think you should have been a cognitive scientist, Chris. That's exactly the kind of question that we ask. And it looks like no, probably not. That doesn't work that way. That it works more like a connectionist network. So the neurons are connected to each other, and the connections between the different nodes in the system change strength depending on experience. So, for example, if I'm used to seeing roosters, then a certain set of nodes are used to firing together. They develop an association with each other. And so to recreate that rooster, I just need to sort of reactivate that system, and all the associations that are built into it then can recreate all of the different aspects of the rooster. It's probably something more like that.
I just love this stuff. I love taking this stuff apart. I think it's fascinating.
Yeah, I mean, maybe you're right. I mean, the fact is that the more you look for a master controller in the brain, we call it a homunculus, a little man, the more frustrated you're going to be because you never find one.
Yes.
Those master controllers themselves are networks of interconnected neurons, and so they do know things. You're right; they know things, but the way that knowledge is implemented is not in a way that it's in a way that's opaque to us, and that has to do with probably the way that the networks are connected with each other.
Right. This is one that the counterintuitiveness of the brain versus our experience of life really comes to your head. This is where the rubber meets the way that you find out, oh no, the road's not there. Like it's whoa. The models we've created based on our own sensory experiences and experience of our life, it isn't necessarily how the brain's doing what it's doing. And I find that just so interesting. Perhaps the best way of explaining it is exactly like you said earlier. Muscle memory has nothing to do with the muscles. You can spend all day long for years taking apart, dissecting muscle tissue, looking for the memories that are in there. That muscle must be there, that tell the muscles what to do. But in fact, you're looking in the wrong place. It actually has to do with the neurons, not the muscles at all. And so we try to impose our models onto the biology of this, based on how we experience things. Then we can end up not getting answers. And to me, that was the most revelatory piece of information as a concept of what's going on upstairs. I was like, oh, just because we experience something a certain way doesn't mean that's actually how it is, And just because our folk psychology is a certain way doesn't mean that's how real psychology and neuroscience actually works.
Yeah, and just because our folk psychology is a certain way doesn't mean that our real psychology is that way. You're absolutely right. I should point out about the muscle issue that muscles probably do have a kind of memory of their own. It's not the kind that we're talking about. But even the fact that muscles change, they do change with experience, right?
Yes.
They can grow, and you could tell which muscles somebody has been using recently just by looking at them.
Okay, so we've got these different systems and these different gateways or different pathways to different types of memory that are doing different things, probably tie into other systems in interesting ways. So where do we fall down in our understanding of memory? What are we still trying to figure out then when we have as much as we have? How many more questions has this brought up, and how many answers are we finding?
Yeah, there's a lot to learn, of course, as with everything in neuroscience. And one way to break it down is to talk about the different levels of analysis that we have in neuroscience. So one of the some of the big questions have to do with what are the actual cellular mechanisms for memory. So we know that neurons change in response to experience. They can one of the ways they change is to change in how they're interconnected with each other, the strength of the connections between neurons. And what are the actual biochemical and physical mechanisms that allow those changes to occur? That's a big area of neuroscience, and there's a lot known about it. It's not an area that I follow. I'm a systems level neuroscientist, but there's a lot of work to be done at that level just to understand the actual biology there. Why does experience change the way neurons work? There's also a lot to be learned at the systems level. How do these systems interconnect with each other? How is long-term memory implemented? What exactly is the hippocampus doing? How do we implement recall? Where is that master controller, if there is one, and how does it work? There's so much to be learned. Short-term memory is a whole other area of research, with the mechanisms of working memory and how they interact with other systems in the brain, executive function, for example. So there's no shortage of things to be learned about memory.
Wow, interesting. Because you have a system here, and so the combinations, when you think about a computer and zeros and ones, which is the analogy we inevitably keep coming back to because it seems to be the only thing we've created that fits at all a model of neurons and connections and things. So you have neural networks, and you have, how we build computers based on our understanding of brains, you have these unthinkably complicated connections. The sheer number of connections possible, and when you look at what's possible with zeros and ones in a computer, you go, wow, well, there must, if that's what we can do with some electronics and some circuit boards, what can we do with this? I mean, you think there must be huge untapped regions or potentials there that we don't know anything about yet. How do memory studies fit into this? Because you have people who have extraordinary ability to say there's this British guy who can recognize faces. He beats computers, and his ability to facially identify people is astounding. I don't know if you're familiar with this one guy I'm thinking of, but he's this guy. You can sit in front of a screen and he's looking for a particular person, and he can just look at crowds and crowds and crowds of people. And there it is, right? And he just has this ability to do that. And it's sort of like you can kind of look at it as a memory trick or something, but it's clearly an ability that he's got that most people don't have. How much does that sort of thing factor into the kind of research that gets done on memory?
And those are really interesting cases. There's a few things to respond to in there. One is that, you said it could be some kind of a trick. And that relates to the idea that our memory is something that we can improve. There are tricks that we can do. There are ways to use our memory that we can learn to do to improve its performance. For example, we talked about working memory pretty briefly and remembering phone numbers. And typically, people can remember about 5 to 7 items in their working memory, that's an ability that we can play with a little bit, because even though we can remember 5 to 7 items, what we consider an item actually matters here. So, for example, if I give you, 5 digits to remember, you can remember those. But if I give you 20 digits to remember, you're not going to be able to do it. But if those digits are in the form of years, so I say the first year is 1975, the second year is 1980, then 1950, and then 1841. Those become new little chunks of information, and you can remember 5 of those chunks because you've turned the numbers into like a single unit. And so chunking is one of the things we can do to improve our short-term memory. And there are all kinds of tricks like that. As soon as you sort of understand the way that memory works, you can start to improve your memory. If you understand how the recall process works and the cues that we use, you can start to implant little cues for yourself to make things easier to remember. So understanding memory and the way that it works is useful for improving our memories. That's one of the points to be made. Now, there are probably some people that have extraordinary abilities that go beyond what the sort of normal distribution of memory is, and those are really interesting cases. One of the cases that I'm familiar with is the guy that was studied by, there's a neuropsychologist from Russia. His name was Alexander Luria. It's kind of the grandfather of neuropsychology. And he studied this guy who had this insane memory where he ostensibly never forgot anything. Yeah. So he would, Luria would give him grids full of numbers on a chalkboard, like 20 by 20 numbers, something like that. And a decade later, he would say to the guy, on June 5th, I had those numbers on the board. What were the numbers? And the guy would read them back. The really interesting insight I got from his description of this case is that this was a disability. We think of this as a super ability, but for this guy, he actually considered it a disability of forgetting. Forgetting is actually an important part of the memory process. Right? We think of it as something we want to avoid most of the time, but if you can't forget, you have a whole new problem not have considered. Let's say you park your car in the same lot at work every day, and you go out to find your car. You want to know where you parked it today, not where you parked it every other day. You want to have those other memories fade a little bit so that you can get the one that you need, right? Forgetting is a useful thing because it helps us sort through the memory and decide what's important and what's most useful and what's most recent, for example. And this guy was so unable to forget that he was tormented by all this information. And he did all these things to try to forget. He would, imagine burning up the little piece of paper in his mind that had the information on it, and it just wouldn't go away. So, it seems like the brain actually does actively forget things, and this is an active process because of this issue. And it's something that we may be able to, some people might not be able to do as well as others.
I'm so glad you brought that point up because it hadn't occurred to me in the same way. I'm gonna make this really silly analogy right now, but I think it fits. I used to, well, up until very recently, actually, I had this sort of goal or idea or sort of utopian fantasy in mind that wouldn't it be amazing to live forever? I mean, wouldn't it be amazing If only we could live forever, and no end of our experiences, no end of learning, no ending life itself, the wonder of life. And I want to keep going. And I don't want to stop until somebody actually seriously invited me to consider what it would actually look like to live forever. What would that really be like as a human being with our limited senses, limited experience, limited amount of ability to remember and learn things? You can only learn so much, you can only experience so much, and after a while, everything's just going to become torturous to you because you've been through everything, you've seen everything, you've done everything that you can physically do. There will come a point where that will happen, where you will cross that threshold, and then it'll be nothing but redundancy forever. And wouldn't that be a kind of hellish torture, in fact? And I thought to myself, oh my God, nobody had ever invited me to do that. And once I thought the thought through, I realized that eternity could actually be torture for a human being in the same way as you just pointed out. Everybody thinks, oh, if I can remember everything, I wouldn't have any problems. Everything would be, I could remember everything perfectly. I could remember all the answers to all the questions and all the things I ever learned and all the stuff I ever knew and all the people I ever met and all this other stuff. To never forget. I mean, wouldn't that be amazing? And then you point out, no, actually, it'd be kind of torture. Exactly. What you really want is to be able to live as long as you want to. And
exactly. I mean, what you really want is to be able to live as long as you want to and no less, right? And it's the same thing with memory. You want to be able to remember everything that you want to remember, and no more.
Hey, everyone. They say that knowledge is power and knowing is half the battle. And you know what? I agree. And thanks to the Great Courses Plus, we get to tap into that power with just a click. With this streaming service, you unlock unlimited access to objective, reliable, and very interesting information on virtually any subject, learning from the brightest minds around the world. You benefit from their years of experience and unique insight to help formulate your own knowledge and perspectives. With over 40,000 five-star reviews on the Great Courses Plus, you truly can master so many skills and subjects. I've said it before, and I'm recommending again, that in these times of political and social upheaval, one of the best courses you can do right now is called Fighting Misinformation, Digital Media Literacy. We are being bludgeoned with data right now, and it's really important you know how to discern fact from fiction. Tap into this power of knowledge. Join me and thousands of other learners and sign up for the Great Courses Plus. And my listeners can check out any course or lecture for free today. That's free access to their entire library. Don't wait any longer. Sign up today using my special URL, thegreatcoursesplus.com/critical. That's thegreatcoursesplus.com/critical. Do it today. I'm also thinking of this woman who's also noted as having this extraordinary ability to recall or remember things. And she was asked, because there's kind of this little club of people who can do this stuff. They're like these memory gurus or whatever, these people who really have this amazing ability with memory. And they were asked, this one woman was asked, well, how do you do this? What goes on in your head when this is happening? And she likened it to a memory palace analogy. She made it out more like a city, and you walk down these streets and the memories are there on the buildings. And she can just, I want to remember this. I walk over to Jones Street and there's the memory, right? Or I walk over, Park Avenue and there's my childhood or whatever. But she had things organized in her mind that this is what she was doing to remember these things. How does that fit into, how does that kind of analogizing or how people explain how they do this, how does that fit into how you guys go about researching what's going on at the biological level?
Yeah, well, there's a link. There seems to be a strong link between location, perception and memory. So I think it makes sense that these memory city or memory palace techniques work. If you look at the hippocampus, one of the things that the hippocampus does, in addition to memory, is to process spatial location. So in rats, we know there are these cells in the hippocampus that are called place cells that respond to specific places that the rat has been, for example. So figuring out the spatial layout of where we are, that's one of the things that early in our evolution was really important for us to remember: the way home, or the way to the tree that has the fruit, or the place where the animals are that I'm hunting. So location for spatial layout is something that we're really good at and is really intrinsic to our neurobiology. And so leveraging that to remember other things by hooking them into different spatial locations makes a lot of sense, and that's probably why that works. So I think that's a great technique that people have developed, and it's one that ties perfectly into what we know about the neuroscience of memory.
Well, certainly it's beautiful for me because it certainly aligns to the way I remember things. And obviously we're talking about this, so it must be that other people are remembering things this way too. With what you were just talking about with spatial memory, because having traveled as much as I have driven around, learn different cities and their layouts. Like I can sit here and tell you and kind of draw out Portland, Seattle, Minneapolis, Kansas City a little bit, Pasadena and Santa Barbara. These places that I lived in Denver now, once you kind of get it, and it's funny because for me, once I was in an area for a certain length of time and I've driven around, I get it now. It took forever for Seattle, though, because I got north and south wrong right from the get-go. I had the orientation wrong. But Portland, I had that place figured out in 5 minutes, right? Because it's all numbered and lettered, and the streets are in alphabetical order even, and it's this very brilliantly laid out little city. Salt Lake City, you can figure that out in 10 seconds because it's all, because there's a temple in the middle and everything extends from that. So some places are a lot easier to learn than, say, Minneapolis, which is a fucking hellland when it comes to trying to figure that place out. Ugh. Anyway, the point is that even now I can look back at those places, and the way I think about them is spatially. I think I actually have the concept of the layout of the city and where the streets are and where things are located in relation to each other. And so rather than thinking about those places in terms of events or people, I think about them spatially. I find that kind of fascinating because I haven't really thought about how I think about those things until you just brought it up just now.
So one of the other distinctions that neuroscientists have made we were talking about explicit memories now, these memories that we know that we know, and even those aren't just all of one type. So it looks like, for example, there might be different systems for memories of things like spatial location and facts versus memories of events. We call these memories of events episodic memories. Like you remember what happened on your third birthday, for example. It's an episode that you can replay in your mind. And there seem to be specific systems for that kind of event recall versus these other things that we remember explicitly. But it's true, you can be out of that city for 20, 30 years and go back to it, and immediately you'll know where to go.
That's right. It's almost easier to stop thinking about it and just let it happen. I know in 3 streets I need to turn right to get where I'm going, so long as I don't think about it too much. If I think about it too much, I might mess myself up with this. And so we do that to ourselves as well, because I think the different kinds of memory we're talking about there are kind of bumping up against each other, or, I don't know, overlapping or contradicting one another even.
Right, like there's something you know about the layout implicitly. And if you think about it too much, you can sort of override that implicit knowledge. You have to let yourself go with it.
Right. And yeah, this is probably not dissimilar to the muscle memory we were going on about with athletics, especially, You can't second guess yourself out there. You got to just roll with it, and hope you're right more often than wrong.
I mean, when you're learning a physical task, when you're learning a procedural memory, there's this interesting interaction between your executive function and the kind of intuitive learning mechanisms you had that you sort of have to navigate, right? Like, I don't know if you ever learned how to play an instrument. It takes a lot of attention in the very beginning to get your hands in the right place and to do the things you want to do. And as those things become more automatic, there becomes this interplay between letting things happen automatically versus, cognitively controlling them, that you have to sort of make that transition. It's a really interesting time in the learning process for me, because you can really see the interaction between those conscious mechanisms and the unconscious automatic things happening.
Yeah, big time. Well, let me ask you this. Phone numbers, for example. This is a great little way of looking at this, because I'm realizing as we're examining this and talking about it that there's kind of two different ways I've memorized phone numbers. I would do it through the numbers, 805-953-8931. I think that was the old Santa Barbara org number. I've had that number memorized for decades because I was, Scientology Santa Barbara staff for like 8 years, and I had to give the number out all the time. And then I'm realizing, I'm looking back on that, I'm remembering the numbers, but I'm also, as a kid growing up, we had rotary dial. And then you had the 9-pad digit thing, right? Which we still have with cell phones now. And the pattern of the numbers start in the top left corner, then jump 2 spaces over, 1 space down, then 3 spaces. It was more of a pattern recognition more than it was the numbers that I was memorizing.
Yeah, spatial patterns are much easier to remember than abstract numbers because they tie directly to these cortical maps that we have. We have this visual spatial system that allows us to recreate the visual patterns of the spatial layout. But a number is something that's totally abstract and doesn't really mean anything. It's just a symbol, right? So those spatial things, tying things to perceptual experiences, like a spatial layout, that is something that can really help with memory.
Yeah, exactly. Or as you mentioned earlier, the thing with numbers. I'll give an example here. We were learning about learning in 9th grade in social studies class, and there was this little memory exercise in the book, and it was memorizing a 12-digit number. And of course, the point being made was you can't memorize it so easily when it's just a string of 12 numbers. But if you bust it out into 3, 3 sets of 4 numbers or 4 sets of 3 numbers, which is how we did it then, it's a lot easier to remember 149, 250, 738, 427.
Is that the actual number they gave?
Yeah, the actual number. I've kept it since 9th grade in my head. And the other funny thing about those numbers is busting it out into the 3 digits. There's one way of accomplishing that, and I remember sitting there memorizing that, but the other thing was the little associations you could make with some of the numbers, because 1492 is 1492, which is the year Christopher Columbus sailed the ocean blue, and that's Christopher. My name is Christopher, so I can remember the first 4 digits by remembering 1492, and that has stuck with me for over 40 years.
Amazing. Now let's look at some of the things you were doing there. So in addition to the chunking, which we talked about, the other thing that you're doing is semantic, is elaboration. One of the things that memory researchers found is that the depth of processing the information matters. So if you have a sort of surface level processing, you're just treating them as numbers, they don't mean anything to you. It's very hard to remember. But as soon as you connect it to deeper meaning, things like your name, Christopher, that was a connection that you made, things become easier to remember because memory has to do with connections. And reactivating these memories through their connections is easier the more connections that they have with your existing knowledge, right? So, and the other thing is memory cues. So we don't remember things unless we have that initial spark, that cue to memory. And the more cues you can plant around, like you've got Christopher Columbus you can think of your name, you can think of maybe what the classroom looked like. All these different cues help us to reactivate the memory.
That's right. In fact, as I sit here right now, I can literally remember the page that those numbers are on. I can remember in a conceptual way in another class later in high school, reading Yeats, Butler, poetry, English literature. I remember reading those things, but I don't remember any of the words. I don't remember what some of the poems were about, I mean, only in a distant way do I remember conceptually. But by conceptually, I mean beyond thinking of the words or the numbers or the letters themselves. I sort of just have this amorphous sort of globular memory of, oh yeah, we studied Yeats in school, Well,
I think we can use this memory to talk about another important aspect of memory, which is its potential inaccuracy. So, because you're going through this recreative process that the brain is, bringing back these images generating the image of the page. And you've been generating the image of the page for, I don't know how long now, but years. And one of the things that happens with memory is that each time we remember something, that is a learning event in itself, right? The actual process of recall changes the memory itself.
You touched on this, and I'm really glad this is coming up now, because this is actually one of the most important principles I wanted to hit on here. I wanted to ask you about this, so please continue.
And we know that because recall helps us to remember things, right? So if you're trying to study for a test, you've got to come up with the information, you try to recall it over and over again. And that active recall helps to lay the memory in and to burn it. And in fact, the more difficult the active recall is, the better the memory will be. If you struggle to remember it and then you actually succeed, you do better. But because of that becomes a new event that we remember the actual remembering again. So you keep generating the image of that page, and if it's slightly different each time, that becomes a new thing that you remember. And after this amount of time, it's really hard to know if that image of the page is really what it looked like, or is the result of this process of memory recreating that image over and over again for years.
That is so true. And I think probably all of us have experienced the jarring surprise of having a memory burned in that you're absolutely positive. You're remembering it exactly how it happened or exactly how it looked. And then you go back and you physically actually see the thing and you go, whoa, this is not at all what I remembered. I mean, it's happened to me so many times. I can't imagine I'm unique in that sense.
Yeah, no, you're not. You're not at all. And this is a huge problem for things like eyewitness testimony.
Yes,
which it's unreliable. Just because we remember something doesn't mean that it happened. We're recreating these images, and our confidence in their veracity is unreliable. We can be really confident that we saw something, and it didn't happen that way. And that's something that the legal system has to deal with all the time.
Well, exactly. And this is one of these traditional things that we've always everybody knows it's true. Everybody sort of accepts it, that the best testimony, the best possible evidence is eyewitness testimony because they were there. They saw it. How could it get any better than that? Well, we have since learned, since the advent of video and photography, that no, we don't remember things nearly as accurately or as well as we like to pretend we did.
Yeah, and it's quite easy to have false memories based on suggestion. So there's this famous study by the psychologist Elizabeth Loftus, where she asked people among a bunch of stories that may have happened in your childhood, do you remember the time that you got lost in the mall and your mother found you and there was a green store there, and they give all these details, and some percentage of the people report remembering this experience even though it never happened to them, and the more they recount the experience, the more little details they add in, because the brain is creative. Every time it recreates this image, it fills in the gaps, and then those acts of recall become new memories, and confidence grows. And so by the time you're on the witness stand, you could recall a story with very specific details even though it didn't happen.
Yeah, exactly. Suggestion is really important to understand when it comes to memory. Leading questions. This is just to make Scientology, the inevitable Scientology analogy here. This is how Hubbard did all of his quote unquote research. Is you can go back and see his transcripts of the work that he was doing with people, and it was nothing but the questions, just flat out, just like, oh well, where's this? Ask them pointedly. Oh, what spaceship are you in? What's the color? Or how many buttons are on the console in front of you? Right? Because he thinks he knows where you're at and what you're looking at and what you're doing better than you do. So he starts asking all these suggestive leading questions. And as you very rightly point out, a certain percentage of people will immediately comply. Oh, yes, well, here's the console is blue and it's got the 10 red buttons on it. And here's all these other memories of your past life experiences that you would swear you came up with yourself. But in fact, we're the product of leading questions.
Yeah, that's interesting. I never really thought about that issue of memories of past lives, but they probably do arise out of this very similar cognitive process where you have some kind of image that your brain recreates that you then trust as a memory at each time it comes up.
Yeah, you can experience it the same way as you do a memory. And this is where the lack of differentiation between where our brains, they don't flag or color a memory or image as a pure imagination versus a live, real memory of something that actually happened to you. There's no flag system in our brain for that. At least it doesn't seem to be the case that there is. I mean, is that?
It's very difficult to tell the difference. That's right. They involve the same basic mechanism, and so that confusion is definitely there.
Yeah, exactly. And apparently it hasn't been enough of hasn't become an evolutionary requirement that we separate the wheat from the chaff, the imagination from the real in our minds in order to get along in the world. So we never had to put that there, and so there's no mechanism for that.
So you touched on L. Ron Hubbard's conception of this, and I wanted to ask you more about this sort of Scientology conception of memory and how it differs, how the model in Scientology differs from the way we've been discussing it.
Oh my God, you're gonna love this, and thank you for asking me, because this is definitely where we're going. Okay. Hubbard posited in the book Dianetics, the Modern Science of Mental Health in 1950 that all memory, everything that ever happened to you, is recallable. You can pull it back up. It's all stored in this thing called your mind. And there's an analytical mind and there is a reactive mind. And then in Dianetics, he also posits a third mind he calls the somatic mind, or the animal mind, or the base mind, which would be like the thing that dogs and cats and animals and things have too. So we as human beings have evolved these analytical and reactive minds, and in them are stored through some mechanism that Hubbard said had to do, couldn't be physical, because he claimed that there was this study done, or he had done some math, trying to store all the perceptions of all the experiences that you have ever had, and he said there simply wasn't room in the brain to store it. He referred to this punched protein molecule model, where a punch in the protein molecule is somehow a memory, if that was the idea, which I guess was current thinking in the 1920s or 30s. So are you familiar with this at all? No, nothing on this. So he put out there and he said, okay, well, I figured out early on that this wasn't possible. The math doesn't work. So he held on to this arbitrary idea that it must be true that we can remember everything that's happened to us, or potentially could.
Why was he committed to that idea?
Why he was committed to that idea, I'm not exactly sure, except for the fact that he seemed really dedicated to it, because it's a fundamental principle of Dianetics, and that by recalling these moments, these particular moments of pain and unconsciousness, if the memory held sense perceptions of pain and unconsciousness, then it was particularly stored in the reactive mind. Whereas the analytical mind, the more awake, aware, conscious, rational mind, the frontal lobe, so to speak, would be to your day-to-day memories, your day-to-day recalls, your day-to-day processing of figuring out, solving problems, things like that. But the memory aspect of this was it was a binary system. Non-painful memories are stored in the analytical mind, and the painful unconscious moments are stored in the reactive mind. And the process of clearing is the process of going into the reactive mind, diving into that well and recalling those incidents through this regression therapy to sort of go back over and relive it over and over and over again. And you and I have now discussed how that's really doing is burning the memory into you, whether it's true or not. But this is supposed to be refiling the bad memory in the reactive mind over into the analytical mind. It literally moves over from this reactive place. And that reactive mind is not just a storage unit, but it's kind of a mechanism of self-protection. Hubbard's idea was evolution created this, so that if you were mauled by a bear one fine day in the woods and you happen to survive, and a year later the perceptions of that bear are recreated or are experienced newly, let's say you hear the bear, or you're in the same general area, or the smells start to smell the same, or somehow perception is repeating history. He's repeating that earlier time. So you suddenly become more alert and aware and are like, wait a minute, something's wrong. But Hubbard said that the language, the introduction of language, like screwed all this up because words can mean more than one thing. So if somebody's beating on you and telling you while they're beating you that you're no good, you're a faker, you suck. But later on in life, if you're subconsciously, this incident of being beaten on is restimulated or is brought back into the memory somehow subconsciously. The reactive mind is feeding you pain, is feeding you this sensory input that you're not even aware of. And you're going to start feeling like you're a faker. You're going to start feeling like you're a phony. You're going to start feeling like you suck because you have these words contained in this memory that is a subconscious memory. It's not an analytical memory. And so you'll feel all these weird, out of place emotions and feelings about yourself, and you'll start doing yourself in. You'll start invalidating yourself, and this kind of thing. And this is the reason why people are introverted, anxious, depressed. It's because of this past trauma. And the words contained in the memories are acting on you as though they are hypnotic commands. That's how he explained it.
It's so interesting. I mean, on the one hand, I really admire the effort at mapping out them, and I can see why it's appealing. And there's kernels of truth in there too, right? I mean, these distinctions between memories that are subconscious, like the kinds of conditioning and habituation and sensitization systems that we talked about, versus memories that are explicit and consciously aware, has a real basis in reality. But there's also things in there that just seem not to connect with reality. So it's the hodgepodge of good ideas and untested ideas that didn't connect with reality.
Exactly. And the thing that threw me for the longest time and gave me that impression that I described earlier of this ideal state of man, those are Hubbard's words, the thing to aspire to, right? I thought a potential to be realized is getting a guy back into the condition where he can remember anything.
The thing to aspire to.
Where it's all there, it's all accessible, there's no amnesia, right?
Right. And so those memories were, you said earlier in what you just described, that the memories weren't physical because they couldn't be contained in the brain. So if they weren't physical, what were they?
Sheets of energy that you carried around with you spiritually, yeah. And it was actual energy, Hubbard described. He said it was a kind of a higher form or higher, finer tune of energy than is known about on Earth these days, that sort of thing. The e-meter, that electronic thing they connect people up to, that's supposed to be measuring the electrical resistance caused by these sheets of energy, which are your mental image pictures. That's the word that's used. The phrase in Scientology is mental image picture.
Interesting. No, so I wanted to ask you about the e-meter. It is related to memory. And am I correct that the e-meter is really just measuring skin conductance?
Yes.
We use those measurements in psychology as well because they do reflect the activity of the peripheral nervous system.
Yeah.
And when your body responds physiologically to things, your sympathetic nervous system is activated, for example, and your heart's beating faster, then we see that reflected in the skin conductance response. And so it's not unrelated to what's happening in the body. And I just really interested in what the interpretation of that signal was in Scientology versus how we interpret it in psychology.
Exactly. No, you guys are actually intellectually honest in measuring skin conductance or galvanic skin response because you're not fooling yourselves about what's being measured. It's skin resistance, and skin resistance changes, and in fact, it's the skin resistance at the surface level of the skin. The e-meter is not sending a signal into the body. It never breaks the skin. It's not a strong enough signal to be able to do that. So it's not like it's going to go through your heart or something. So it's really just measuring that level of skin resistance. And as you say, with sympathetic, and I also believe parasympathetic nervous systems go into play when you're asking questions of a sharp and pointed nature, or you're making a person nervous. That's why it's part of a lie detector polygraph setup, and you'll get interesting responses on a needle or on an ink pen when you are measuring this stuff. And the interpretation is where all of the truth and lies about all of this are, because there is truth connected with the fact that an increased heart rate, an increased blood flow, an increased surge of adrenaline can indicate certain things. But what does it indicate exactly? Well, until you consult the person specifically and individually, you don't really know. But in Scientology, there are these blanket statement made about this stuff. Everybody's the same, so if the needle moves to the right, that's called a fall on an e-meter. It's just a needle on a dial. You know, you ask a question, have you ever stolen an apple? And boom, the needle moves. So you look like you stole an apple. It's simple, Simon. And so science flies out the window in the face of this kind of simplicity. And that's what Hubbard reduced the mind down to. And so Scientologists believe that it's these sheets of energy that are physically impinging on the body that cause the change in electrical skin conductance. It's, you know, it has nothing to, you see, you never...
Interesting term, sheets of energy. I'm just so curious about how the sheets are separated from each other. Is it they're two-dimensional? Is that the idea?
He never goes into the details of this. I'm literally giving you the deepest he goes, right? Is the sheets of energy of a kind that is electronics not known about on Earth yet. Oh, and you can use these kind of electronic flows. These were used by Thetans to steal pictures from other spiritual beings. Thetans, right? To create new false memories, steal other entities' memories, because you could just go and steal them because they're just sheets of energy, you know? You can take possession of them. And this is where you can have fake memories come from and stuff like that.
What's the relationship between the Thetans and memory?
A spiritual entity in and of itself is total knowingness. It doesn't have to have a mind or a body in order to live, and it doesn't keep memories as such. It simply knows. So if it wants to know something, it just goes out, boom, 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 and it just knows, right? The mind is a separate energy box, I guess you could say, that the Thetan's sort of hauling around with itself from life to life to life, accumulating these memories that a spiritual entity or a Thetan is compelled to make or create. Kind of like Jacob Marley and his chains. You know, the Thetan is the source of everything. So the Thetan is the thing that is creating these sheets of energy, you know, one every 1/72nd of a second. So you're creating like 72 of these things every second, these three-dimensional pictures. And you're storing them in the mind. And then you should have full access to it. And all of this accumulated stress and trauma contained in these pictures is the source of your travails, basically. And to somebody who's looking for fairly simple but kind of complex sounding and sort of interesting answers to questions that we don't really have, or you got to dive into neuroscience to find, you know, it appeals to a certain mindset.
It's so detailed in certain spots and so vague in other spots. That's what's so interesting.
Yeah, that's the mind. That's actually a little bit of the mind trap of it, because I would get caught up in, you know, obviously even 7 or 8 years out of this, I still remember all this stuff very, very clearly because I was so interested in it and the mechanics of it. And I was always frustrated at coming up short in Scientology with the answers to these questions, because I'd ask questions like, well, what kind of energy? How's it stored? What do you mean? Where is it? You know, and how does this work? And coming up with these vague ideas, you know.
When you ask those questions, like, is there somebody? Is there a division of expertise within Scientology? Like, is there somebody who like really knows all about the memories, and somebody else who knows all about the sheets of energy, or is it not like that?
Not like that. Not exactly. No, there are a lot of books. There are thousands of lectures recorded, and somewhere in all of that knowledge is the answer to every single question you ever had, supposedly, you know, quote unquote. So the idea is you study it, and eventually you'll get all your answers, and there are indexes and tables of contents and things like that. I mean, you can look stuff up. There are thousands of written issues that Hubbard wrote, bulletins and policy letters and things. I mean, it's a tremendous library of information. So that itself is one of its features, because they say, well, look at all this knowledge, look at all this accumulated discovery of information. It can't all be fake. I mean, look at all of it, right? You know, who would write all this stuff if none of this was true? The sheer size and scope of the work is kind of itself a selling point as to why it must be true, and the answers you seek are somewhere in there.
And all that work, it's not like electronic documents, because you, at least when you were involved, it wasn't an internet thing. You had a physical library that you had to go to, or some place where all this information was stored?
Yep. In fact, they have little libraries in every single Church of Scientology. It's called the Qualifications Division Library. And there are all of Hubbard's stuff, you know, you can go in there and peruse and look and get corrected on stuff and study it. And there's classes and courses and study of this material in a kind of supervised situation where you have assistants and you're supposed to learn all of it. The idea is it's a path of personal discovery through Hubbard's discoveries of life, the universe, and everything. So that's where I got my ideas of memory from a very young age. And I was convinced that we have this potential to remember everything. It was all there to be remembered. And in fact, the ultimate level of Scientology, OT level 8, has the end result of freedom from amnesia on the whole track. And the whole track refers to the entire series of incidents that have happened to you all the way back. Not just this lifetime, right? So this lifetime, your memories are called a time track. And all of my lives, the billions and billions of them that you've had in your entire existence as a spiritual entity, is the whole track. And the cure for amnesia on the whole track is the highest level of Scientology. So memory is quite into the DNA of what Scientology is really all about.
Wow, that's really interesting. You know, you can contrast that to some other spiritual practices where the goal is quite the opposite. You know, to change your consciousness such that you're experiencing the present moment completely and nothing else. That you're not experiencing the present in terms of what you've learned about from the past and not seeing it through the lens of your learning. So this is one of the other problems with learning. We've talked a little bit about what it's like when you can't forget. The other problem with learning is that, you know, it biases your perception of the present. And most of the time that's good because it gives you information that you need. But it can also lead to misperceptions because we learn biases that aren't helpful. So, you know, it's really interesting to me that Scientology is so focused on remembering everything, whereas these other traditions are focused on remembering nothing and just being.
Exactly. And the funny twist at the end of the whole line, and this is the real mind traps of Scientology, is that you get to the very, very top and you've invested hundreds of thousands, you know, maybe millions of dollars at this point, certainly hundreds of thousands of dollars to get to this level. You've sacrificed years of your time and energy and effort, and then you're told at this highest level, actually, you're just making it all up all along. It's all fake. That's all the memories and the ideas and everything that's happened to you. You were just mocking it up. You were just kind of creating it. It's not really that big of a deal. It's no big thing. It's just your imagination anyway. And, you know, at the end of the day, you're just a happy little, simple, silly little spiritual entity who's just bouncing around through life, and all that stuff doesn't really matter anyway. And that message has really messed with some people's minds in a very significant way. In fact, it's not completely unwarranted to say there might have even been some suicides from that, to get real serious about it. I mean, it's that the reveal at that ultimate level of Scientology is such a reverse of what you're tuned into the whole time, that it's sort of like Scientology is trying to have its cake and eat it too. It's exactly the principle you just mentioned, that you get to a place where none of it matters. It's that it doesn't, you know, it's not important, and yet you've been building it up this whole time. And it gets also mixed in with false memories of other spiritual entities or thetans, right, which are stuck to you by the thousands, which you also have to spend a lot of time on these OT levels exorcising, getting rid of these spiritual entities, these body thetans, and he's messing with your memories.
Right. You've done all this work for your whole life, and then it's for nothing in the end, is what you're saying.
Exactly. You get to the end and you find out curtains parted and there's nothing there.
You're not supposed to know that until you get to the end, right? But the information has leaked now.
All of this is available on the internet now, and up until, 20 years ago or so, it wasn't. So People didn't know.
How much do you think the people who are in Scientology now know this stuff?
I would say none of them know it because they keep themselves from knowing, because that's information control. But outside of Scientology, everybody. And it was a big thing for me to realize coming out of Scientology and learning about all this stuff, that people in the outside world actually know more about Scientology than Scientologists do. That's par for the course for destructive cults. You can pretty much say that about almost any of these groups, because the information control and the compartmentalization of the information and the way people or the members are controlled, it's intense. The word control fits. It's a real concept. These people's minds are controlled. So, so they deny themselves information that would free them from that control.
So the irony is that maybe by leaving Scientology, you actually achieved its greatest level, because now you think that it's all not worthwhile.
That's exactly how that works. So you can see my obsession, or my interest, at least, not obsession. I think that's too strong a term, really. But I think my strong interest in memory, has come from that. And so to learn that it's actually radically different, intensely more complicated, but there are multiple levels to it. But there's a lot more going on in the brain than a simple recording of mental image pictures through the sense perceptions that are stored in sheets of energy somewhere. I mean, that's a very simple Simon model compared to what we're talking about with, hippocampi and neurons and, and all that.
That's right. I mean, it's incredibly complex, and we don't understand it. Hey, maybe it'll turn out to be sheets of energy, but it doesn't look that way right now.
I even to this day, I am still constantly searching for a connection or a potential connection between the physicality of what's going on with the brain that we can sense, measuring experience, and this sort of spiritual experience that I could potentially be. And I keep coming up short. I keep finding no evidence of a connection of some kind, and continuing evidence that we're really just fooling ourselves about it. And I understand the need for it. It's not a want. It's not a desire. I really do get that it is a need on the part of human beings to have, paranormal, extrasensory, spiritual beliefs. But there has to be something more to this than, just this mundane blah existence. I get that. I get that viewpoint. I lived it for decades, so I'm totally tracking with that. But the more I dive into this stuff and talk to you and read and, other neuroscientists and stuff, the more it seems clearer and clearer that we're either looking at this really wrong, or there is no such connection. We can't find any such thing, I mean, I don't know. What do you think?
I think the true spiritual journey involves understanding what you really are. And that's what we're doing. I mean, when we're looking at ourselves and looking at the brain and seeing things like, there is no ghost in this machine, that, some of the things that we think about ourselves are illusions. That is, to me, a spiritual insight that we have. It shows what we actually are and how we're connected with the rest of nature and where we fit into reality. So I don't think it's separate. I think that is science can be part of the spiritual understanding of the world.
I think that's a great way of putting it. I really like that. I like where you put that. Okay, so let's go ahead and move toward wrapping up here, because we've been at this for a while and we've talked about some really interesting stuff, and of course segued into Scientology stuff, which I knew we were going to have to do just because of the memory component in Scientology. It's just such a strong element of it that I knew we had to tie that in. But where are we going with this? Are we like, if we're going to look at this in terms of, I don't know, maybe one day of looking at it might be if we had if we had a list of all the questions we have about memory and the brain, how many check boxes, how many tick marks are on that list? I mean, how far down the line are we in terms of, coming up with answers?
I have a different metaphor that I like to use. Instead of a checkbox, I think of it more as a picture that's slowly coming into focus. Right? And we see the sort of blurry outlines of the picture. We can see the light areas and the dark areas, but a lot of the details need to be filled in the picture. And of course, when you fill the details in, the picture can change a lot. And sometimes when you fill in the details, you realize you have some of the big parts wrong too. But that's what it is right now. It's a blurry picture with a lot of details that need to be filled in.
Okay, that makes sense. So we're tuning. At least we've got a picture now. We know a lot, and this is good. This is really good because it's always a little hard to tell sometimes. I get frustrated sometimes, not with any individual, of course, but just the necessary slowness of the process, the difficulties of the process, the truly immense questions and the confusions and problems that we're trying to be dealt with and how to go about it. It's not a straightforward thing. It's not like setting a bone. It's not as clear cut. There's so much more to it because we're having to interpret everything through what people are telling us too, You have to take the guy's word for it that when you say think of a rooster, that's what he's doing, because ultimately, I mean, the guy doesn't particularly have any reason to lie to you. And of course, this is why you do more than just a series of one, but it's a complicated field. How do you know what somebody's actually thinking of? Well, they have to tell you.
I mean, we have some indications that they're telling the truth in that what's happening in their brain when they think of the rooster is similar to what everyone else looks like when they're thinking of a rooster. So unless everybody's lying to us and thinking of something else, but you're right. When we're studying conscious experience, ultimately we have to make some connections with people's report of their conscious experience. We can't ever experience it ourselves directly.
That's right. And the difficulties of that are not even the lying. I mean, I'm using an extreme example there, but even the interpretation of the experience and the vocabulary the person has available to them and how they're going to go about relating the specifics of the experience and then you guys at the receiving end of that then have to interpret it and work it out and all of that. So it's a complicated affair, and I'm curious. When you mention that different people have the same areas firing off, those similar patterns firing off, is it same, or is it similar? How wide are the varieties here?
Yeah, it's a good question. There are enough commonalities in perceptual experience that we can tell from one person's brain what someone else is imagining in terms of vision or hearing. We've been able to do that with our data. And we've been able to do it with more complicated things like stories. We had people read a bunch of different stories, and we could tell which story they were reading from their brain activity. And we were actually able to do this across different languages. We translated the languages into Chinese and into Farsi, and from the brain activity in someone's brain reading the same story in Chinese or Farsi, we could tell which story they're reading, even though languages were different, because the meaning was the same.
No kidding. Now that is interesting.
Yeah. So there are some deep similarities, some deep principles in the way that the brain is organized that allow us to have common experiences and to communicate with each other. There are also differences among people. There are idiosyncrasies, and nobody's exactly the same as well. And those differences between us are also interesting, and they're things that we study. But so there's both. There's universal principles. You think of a brain, I think of it like a face, where everybody's got two eyes and a nose and a mouth, and generally the eyes are above the nose, right? Everyone's got the same features, and so I can tell whether you're smiling. If I know what a smile is, I can look at someone else's face and tell whether they're smiling. But of course, they're all incredibly different as well, and they have differences in the details that make them unique.
Exactly. This actually, immediately, of course, now I start flying off in other directions, but I think of the linguistics and the potentiality here because, one thing that I've learned over the years in talking to international friends is how language literally creates different ways of thinking. A person who's brought up in Germany, a person who's brought up in France, Italy, China, America, they're going to look at things differently simply because their languages are different. And the concepts that they're exposed to through learning their language are different. You have concepts in German that simply have no English equivalent. We have to reconstruct that word some other way or just adopt their word, which is, I don't know, pretty much how English has grown. It's kind of the ultimate language that way. But, like zeitgeist. I mean, there's no English word for that. It's just a concept. So you get a little tiny difference in the way you think as a result of these different concepts. And I can only imagine, it's encouraging to me that people are reading stories in different languages and coming up with the same mental imagery, the same thought processes or patterns. But I think there's a future here in understanding how language affects our thinking ultimately by, studying stuff like that.
how language affects our thinking is such an interesting question. And there's this extreme version of the theory that you just articulated called the Sapir-Whorf hypothesis in psychology, that the words that language that people have can even affect their perceptual experience. So this is kind of like the Eskimo having 20 different words for snow story, which turns out to be, there's not too much empirical evidence for that. The fact that the words allow people to distinguish things. There's a little bit of work that goes on in terms of color. So apparently there's some tribes in South America that have different ways of dividing the color spectrum. So instead of having just a word for blue and a word for green, there's one word that's blue-green. And so then the question is, do they just experience that? Do they really just see that as one color, and they can't distinguish between blue and green, or can they? And it's actually a really difficult question to answer. People have tried.
Exactly. This is the fascinating stuff. This is the part that you just go, oh my God, this is so interesting to try to dissect thought, and personality and our biases and the language and all this other stuff. It's all just part of this package of us. And I just find it endlessly fascinating. So I think we're going in some pretty interesting directions with this. What do you think? Let me ask, let's wrap up with this, because I've been meaning to ask about this. Elon Musk is talking about this whole neural link thing and the literal chip that you could implant and be connected brain-wise to the internet, to outside information, to memory systems. I mean, there's all kinds of question marks connected with the stuff he's been talking about. And now that I'm talking to an actual neuroscientist about this, I'm curious, have you crossflowed any of this? And what are your thoughts about what he's doing?
Man, yeah, I have a lot of thoughts about this. We're going to have to do a whole separate show on this one.
I'm curious enough about it to talk about it for a while.
Yeah, I mean, I would just treat the topic not specifically about what Elon Musk is doing, because I don't know the details of Neuralink, but the general issue of brain-computer interfaces and what their potential is really interesting. And we do have in the lab already, there are these kinds of interfaces. It relates a little bit to the kind of work I was talking about before, where we could decode people's experiences from looking at the brain activity. We measure that with fMRI. But if you have even better measures from actually making contact with the brain, you can do even better at decoding things like visual experiences or intentions to move. This is something that's been done in the field of trying to help people with paralyzed or amputated limbs, for example, interface with prosthetics. So if you can have a chip that's directly tied into the premotor cortex and then decode the signals to allow somebody to move a robotic arm, for example, that could be a really important medical advance. And those things are definitely about to happen. There's so much that we can do there. I think the fuzzier issues that often come up in talking about how the brain can interface with technology is this sort of issue of like, how much of your mind can you upload into a computer? And that one is a much stickier issue, because I think a lot of the people who think about it, include in the tech world, don't appreciate the extent to which the brain is embedded within the physical body and interacts with it and depends on it, and how much of our experience is tied to our physicality and the feelings that we have from that originate in our bodies. And so there's a lot of problems with the idea of a sort of disembodied consciousness that we can get into. That's a sort of general sketch.
Yeah, I understood. And I think we should probably do a whole show on that, actually, because that's a really important thing. And something that I didn't get turned on to until I was reading the theory of constructed emotions. And it's Lisa Feldman Barrett's work on that, where she goes into interoception and what the brain is doing and how she defines it as a neuroscientist. She defines the brain as this thing that exists as an organ in your body whose entire purpose is to regulate the systems of your body. And so if you look at the brain that way, it's inseparable from a body. It's not this idea of the floating brain and the tank sort of thing. That becomes sort of what would be the point? Because there's no systems it's regulating now. It's just this gelatinous mass sitting in a tank. What's it doing?
Right. And some neuroscientists have gone so, and Antonio Damasio believes that a brain can't actually be conscious without a body. So if the brain were in the vat, it might not even be conscious. I think my view is somewhere in the middle, that the brain depends so much on the body that any kind of disembodied experience would be very, very different from our experience.
Exactly. And the thing about it, I guess I'll just do this and then we'll wrap up here because we're going to get to that other show. But I think it allows it, I think it allows it to adapt to new things. And I think we even talked about it in an earlier episode about what if you have a third arm? Would a brain be able to adjust to and control that? Well, eventually, yeah. It can rewire itself that way, especially as in a young brain. So I think, there's potentials there, but this idea that you're just going to go do a brain surgery and stick it in a vat and connect it to a computer, and then we're going to have, I don't know, what was that Johnny Depp movie, Transcendence?
Well, I think the connection you just made is a nice wrap-up point because it ties us back to memory, the plasticity of the brain. Maybe this will be the next form of memory that we deal with, how the brain adapts and changes in response to being connected to technology.
Yeah, there we go. Exactly. And we'll just start testing the limits of this plasticity and what it can and can't do and all that. Interesting stuff. As always, thank you so much for being on the show here. I really appreciate it.
Thank you for having me. Great conversation as always.
Awesome, man. Yeah, I agree completely. It's always informative, folks. I hope out there that you were informed, entertained, and maybe enlightened a little bit by this episode and, a little bit more about yourself and your memory and how things work up in your head. If you're finding my podcast at all informative, entertaining, and educational, then please consider joining me on Patreon or helping through PayPal. That's always good for a one-off as well to kind of keep the lights on and the show going because that's what keeps it going. It's powered by you. Thank you very much for your support and for your viewership, and I will see you next week. Bye-bye.